So this is the 2014 Leaving Cert Ordinary Level Paper 1, and we're looking at question 9. A small rocket is fired into the air from a fixed position on the ground. Its flight lasts 10 seconds. The height in meters of the rocket above the ground after t seconds is given by the function h equals 10t minus t squared. Okay, part A says complete the table below. So we're given all these times in this row here, and we have to fill in the heights for these times. So some of them are done. So h is equal to 10t minus t squared. So for the first one, h would be equal to 10 by the t, which is 0, minus the time again squared. So that would give a 0 when you work this out in your calculator. So that would go in there. The second one then, h is equal to 10 times 1 minus 1 squared. And that gives me a value of 9. Do it on your calculator, so that goes in there. And just do one more, 10 bracket 3, sorry. 10 bracket 2. So I'm just putting each of these t values into the function. 10 bracket 2 minus 2 squared. That gives me 20 minus 4, which is 16, is in there. And you just go on and on doing these. So I'm not going to bother doing all of them. Just continue on there. Do 3, 4, 9, and 10. And the values you should get are 21, 24, and for 9 and 10 you should get 9 and 0. So you can also do this using the table function in your calculator. If you, instead of h, you treat that as y and the t as x. You can just put this in as a function in y and x and put these values in and get it with the table function. But there isn't too many to do here, so it's easy enough. So that's the table filled in. Part B says, draw a graph to represent the height of the rocket during the 10 seconds. Okay, so this graph here, which they've given, has height going up the y-axis and time across the x. So t and h. So you're plotting the values that you got in the previous question. So you had these coordinates. So in other words, the coordinates would be 0, 0 would be one coordinate. Then you've got, remember, it's t across the x-axis, so it's t first. So it's coordinate 1, 9, 2, 16, 3, 21, 4, 24, 5, 25, 6, 24. So you're plotting all these coordinates on the graph. 8, 16, 9, 9, and 10, 0. So all these coordinates here you're going to plot on the next page. So let's have a look. We had 0, 0, which was here. And we had 1, 9, which would be there. And we had 2, 16, which is here. Then we had 3, 21. So 3, 21 would be there. Then we had 4, 24, which would be here. 5, 25, which is there. And then 6, 24 going back down. 7, 21. 8, 16. And 9, 9. And finally 10, 0. So back down to here. So you can see there that it's formed this parabola shape or parabolic shape, which we're going to now draw as smoothly as we can. So You got to draw this as smoothly as you possibly can. It's hard for me to do it here on this. You should be able to do it nice and smoothly with a pencil. So you can see that's not great there. And remember, you're probably going to be using this to read some values off. So you got to try and do it as smoothly as possible. So mine doesn't look too good there now, but you'll have better answers than I will using a pencil. Okay, so there we go. That's not great, but you get the idea. Okay, so that's the graph done. Part C says, use your graph to estimate the following. The height of the rocket after 2.5 seconds. So if we go back and we want to get the height of the rocket after 2.5 seconds. So let's see, 2.5 seconds would be here. So from 2.5 seconds, draw a line straight up till you hit your graph. And from there, go across and take the reading off the h-axis, the height axis. So the height there would be just under 19, so we'll say 18.8. So it's 18.8, and that's going to be in meters, because the height was in meters. Now your answer may be slightly different, something around 19. Depending on the graph, everybody will get a slightly different answer. Part 2, the time when the rocket will again be at this height. So when will the rocket again be at this height? Well, that will be if you continue the line across, and then from there you go down. So you can see that it's going to be the time when it will again be at this height will be at 7.5 seconds. Part 3, the coordinates of the highest point reached by the rocket. Well, the highest point reached by the rocket is this point here. The coordinates of that point, you can drop down a line, but you can see it's actually above 5, so it's 5,25. Try that again. 5,25. So that's the coordinate of the highest point. Part D1 says, find the slope of the line joining the points 624 and 721. Okay, so for finding the slope, we can use the slope formula, which I've taken from the tables book here. So we label these 2 points x1, y1 and x2, y2. And then we just sub these into the formula in the correct position. So the slope will be equal to y2 minus y1. It's 21 minus 24 over x2 minus x1, which is 7 minus 6. So when we do that in the calculator, we get -3. So that's the slope joining these 2 points, the slope of the line joining these 2 points. Part 2 says, would you expect the line joining the points 721 and 816 to be steeper than the line joining 624 and 721 or not? So these are the 2 points we've just done. Give a reason for your answer. The 2 points we just did there, they have a slope of -3. So now we're going to do the slope of these points here. So this time we'll call this point x1, y1, and this point here x2, y2. We're going to use the same formula then, again from the tables book. So the slope is equal to y2 minus y1, so that's 16 minus 21 over 8 minus 7. So that gives us a value of -5 on the calculator. So because the absolute value of this, or the, it's a negative slope, but if you take, the slope is, the positive value of this is 5, the positive value of this is 3, so the absolute value of this is bigger, so it would be steeper. So we can say, to answer the question, yes, the line is steeper because the absolute value of -5, which is 5, the absolute value of -3, which is 3. So we can say because 5 is greater than 3. So that's the end of part 2. Part E1 says find dh dt. So we have to differentiate the function with respect to t. So if you remember h, let's go back and have a look at the original. H is 10t minus t squared. So h is 10t minus t squared. And we're going to find dh dt. So we're going to differentiate with respect to t. So we're going to use this rule here from the tables book. First rule of differentiation. This is our function. We differentiate a polynomial like this. So 10t is just, that's t to the power 1. So bring the power to the front, times it by 10, and you reduce that power to 0, and t to the power 0 is 1, so it's just 10. Okay, and then for this term, bring the 2 to the front, so it's minus 2t, reduce the power by 1, so it's just 10 minus 2t, that's 10 minus 2t is dh dt. Part 2 then says hence, so using this, find the maximum height reached by the rocket. Okay, well the maximum height is when dh dt is equal to 0. So in other words, if 10 minus 2t is 0, what's the value of t? At what time does this happen? So if we bring this minus 2t over here, it becomes positive. So you get 10 is equal to 2t. So that means that t is equal to 5. So if t is 5, the question though is find the maximum height. So the maximum height will be when the time is 5. So if I put this then back into the original function, the height will be equal to 10 by 5 minus 5 squared, minus the t squared. Substituting that in here. And that gives me 50 minus 25, which is just 25. So the maximum height is 25 meters. And this is in line with our maximum point being 525 from the previous question here. And it matches the graph. Okay. Part 3 then says find the speed of the rocket after 3 seconds. So speed. Now, we know that speed is the rate at which distance changes with respect to time. So we can think of the speed. The speed is actually dh dt. That is the speed. And we know that dh dt is equal to, from the previous part, 10 minus 2t. So they want to know what is this after 3 seconds. So that's our t value. So we're going to put 3 in for t here. So we get 10 minus 2 times 3. And that's equal to 10 minus 6. So that's 4. And it's going to be meters per second because the units for the height were meters and the time was seconds. So meters per second, 4 meters per second. Okay, and the last part F, Find the coordinates of the point at which the slope of the tangent to the graph is 2. Well, the slope of the tangent to the graph is also another way to describe dh dt. That's what dh dt is, the slope of the tangent to the graph. So dh dt, they want to know the coordinates at when this is equal to 2. So we're going to let dh dt, which is 10 minus 2t, be equal to 2. And now we're going to solve. So I'm going to bring the minus 2t over again, becomes positive. And this time the 2 will come over here to the other side, become negative. So that's going to give me 8 on the left is equal to 2t. So that means that t must be 4, because 8 is equal to 2 4s. So the coordinates of the point, I know t is 4. So to find the h coordinate, I'm going to sub that then into the original function. So if you remember, the original function h was 10t minus t squared. So that's going to become h is equal to 10 by 4 minus 4 squared. And that gives me 40 minus 16, which is 24. So when t is 4, h is 24. So the coordinates then of the point where the slope of the tangent is 2 is 4, 24, ht. So that's the end of part F and the end of question